number 1, we are going to be talking about the characteristics of quadratic functions. First, they want you to draw the axis of symmetry. What do they mean? Where to cut it in half. So to cut this parabola in half, wouldn't you have to go straight down the y-axis? And isn't this line cutting through the x-axis at 0? So the equation of that line is x equals 0. What is the vertex of this parabola? Y'all, where's the point where the parabola changes directions? 0, -3. Is that point a minimum point or a maximum point? Minimum. The vertex for this one happens to be the lowest point on the parabola. What's the y-intercept? It's also 0, -3. What's the domain of this parabola? Domain? Guys, domain. Negative infinity to positive infinity. You can go left forever, and you can go right forever. What about the range? -3. It's the lowest you can go to positive infinity because you can go up forever. Now, on this one, parenthesis on infinity, but bracket on the -3. Okay, interval of increase. Okay, pay attention because this is kind of new for y'all. You got to read from left to right. So from left to right, aren't we increasing from the vertex up the right side? So, another thing you have to keep in mind with intervals is they only care about the x values. So when it started increasing, what was the x value of this point? 0. So it increases from 0 to infinity. Alright, then on this side, it is decreasing. When did it start decreasing? Okay, interval of decrease. I already shaded where it's decreasing, but we were trying to decide when did it start decreasing. Well, what does an arrow mean? Infinity. Is it positive or negative? Intervals have to do with x values. Is this left or right? So it's negative. So it decreases from negative infinity until it gets down here at the vertex, and the vertex's x value is 0. Okay, now let's try number 2. Where would the axis of symmetry be? That we don't write the axis of symmetry as a point, we write it as a line. Wouldn't this be the axis of symmetry? And what is the equation of that line? X equals 0. Guys, 0, 0 is an ordered pair. The equation of a line looks more like this. Something equals something. Isn't that a line that crosses the x-axis at 0? So the equation of the y-axis is x equals 0. Just like the x-axis would be y equals 0. For this one, isn't this the vertex? And where is it located? 0, 0. On this particular parabola, is that vertex the minimum point or the maximum point? The minimum. It's the lowest point on the parabola. What is the y-intercept? 0, 0. It hits at 0, 0, right? What's the domain? Right. You go left forever and right forever. What about the range? 0 to infinity. But since 0 is a stopping point, you put a bracket. Interval of increase. So this time, isn't it increasing from the vertex up the right side? But remember, we only care about x values. So what is the x value where it started increasing? 0. And then where did it end increasing? It doesn't, so positive infinity. Okay, and then that means it would be decreasing on the other side of the parabola. When did it start decreasing? Negative infinity. Because even though it's up, we don't care about up right now. We care about x, which is left or right, and this is left. So that's why it's negative infinity. And when did it quit decreasing? 0. All right, number 3. Where would the axis of symmetry for this one be? X equals 0. Isn't it a line that cuts through the x-axis at 0? Where is the vertex this time? 0, 2. Is the vertex a min or a max? This time it's a max because the parabola opened down, so the vertex is the highest spot on it. What's the y-intercept? 0, 2. What's the domain? Right. Think about it. Aren't all of these parabolas going to go left and right forever? What about the range? Negative infinity to 2. Because you can go down forever, but when you go up, you can only get to 2, and you put a bracket because you stop there. Interval of increase. This time the interval of increase occurs on what side of the parabola? The left. So when did it start increasing? Negative infinity, forever left, right? When did it quit increasing? 0, x values. And so if it quit increasing at 0, doesn't that mean it started decreasing at 0? And decreased forever to the right, which is positive infinity. The hardest thing about intervals is remembering that it's x values only. You could care less about any y value up there. You only care about x values. Okay, number 4. This time, where would the axis of symmetry be? Right, so what's the equation of that line? X equals negative 2. It's a line that cuts through the x-axis at negative 2. Now where is our vertex? Negative 2, 0. The x value shifted left 2 units. It didn't go up or down, so the y value is still 0. Is your vertex a max or a min? A min, because the parabola opens up. Where is the y-intercept now? Guys, the y-intercept is where the graph cuts through the y-axis, which is here, and that's 0, 4. What's the domain? Right. What about the range? 0. Remember, range is y values. That point has a y value of 0. So it goes from 0 to positive infinity, bracket on 0, parenthesis on infinity. Interval of increase. Isn't it increasing from the vertex up the right side? So when did it start increasing? Negative 2, and then it increased forever. So that means the decrease is occurring on the left side, which started at and quit at negative 2. Is it starting to make sense? Why don't you try 5 and 6 quickly by yourself, and then I'll go over the answers. Shh. Number 5. This time the axis of symmetry would have to cut right through the x-axis at 1. So that is x equals 1. The vertex is right here. That's right 1, down 1. So 1, negative 1. Oops, I read it wrong. The vertex is a maximum point because the parabola opens down. The y-intercept is now right here at 0, negative 2. The domain is all real numbers. It goes left forever and right forever. The range, it will go down forever, but it will not go up forever. The highest it gets on the y-axis is right here at positive 1. Interval of increase. It is increasing on this side. It started increasing at negative infinity because forever left to go. And then it quit increasing here, which has an x value of 1. For decreasing, it starts decreasing at 1 and decreases forever. So the interval of decrease is 1 to infinity. Okay, number 6. I know. Okay, the axis of symmetry is right here. which is the equation x equals negative 1. The vertex is now right here because it shifted left 1 and up 3, so that puts the vertex at negative 1, positive 3. Since the parabola opens down, our vertex is a maximum. Since the parabola shifted over and up, the y-intercept is now at 0, 1. Domain is left and right. No matter which way you go, you're going to go down, but aren't you also going to go left forever as you go down and right forever as you go down? So all real numbers. Then the range will go down forever, but it will only go up to a y value of 3. For the interval of increase, it's increasing on the left side, which is negative infinity to negative 1. Because remember, we only use x values, and it quit increasing right here, which is an x value of negative 1. And that means if it quit increasing at negative 1 is where it started decreasing, and it decreased forever to the right, which is positive infinity. You don't have to worry about brackets for intervals, just domain and range. Okay, now flip to page 21.
Oh, yeah. Oh.
Okay, what's different about this page?
It's got equations.
Okay, but what do you, right, but what do you have? A calculator. So the first thing you need to do is go to y equals, clear out anything that's already there, and now type in your equation. 2x squared plus 8x plus 1. Once you've typed it in, you can graph it to have a picture. So what is the domain? Domain. How far left will you go? Right. Haven't you kind of noticed every parabola has the same domain of negative to positive infinity? Now, let me just say this. In the future, you're going to learn about parabolas that actually open right and left. Okay? And when that happens, your domain will no longer be all real numbers. But for right now, since we're only dealing with parabolas that open up and down, your domain is always going to be negative to positive infinity. Okay? Now, your range is affected by wherever the vertex is. Where is the vertex? Okay, well, since it is kind of hard to see, let me show you an easy way to locate it. Well, if you look, we pretty much know it's negative 2, right? So, look at this. See that word that says table? If you hit second table, negative 2, negative 7. There it is. Okay? Because look at these y values. Out of all of those y values, isn't negative 7 the smallest one? So that lets you know that's the lowest part, which is the vertex. Negative 2, negative 7 is your vertex. Okay, graph. Okay, so now that we have a vertex, what's the range of this parabola? How low will it go on the y-axis? What's its lowest y value? Lowest y value. And what's its largest y value? Infinity. So negative 7, you put a bracket, and then it goes up forever. Now, is the vertex for this one a max or a min? A minimum. The vertex is the lowest point since the parabola opens up. Where will the axis of symmetry be? X equals negative 2. Because the axis of symmetry is a line, so you have to write the equation of the line. Interval of increase. Isn't it increasing from the vertex up the right side? So where would that be from? Negative 2 is where it starts, and then positive infinity. Okay, so decreasing would be on this side. Where did it start decreasing? And then it quit decreasing at negative 2. So it started decreasing on the left side forever ago, which would be negative infinity. And then it quit decreasing when it got down to the vertex, which had an x value of negative 2. Okay, in behavior. It's been a while since we've done in behavior, so let me go over it. The x-axis only runs 2 directions, left and right. So what do you think negative infinity is? Left. So if you're on this problem and you decide to travel left, the y values are going up, so positive infinity. So if x approach negative infinity is left, x approaches positive infinity is, y'all, listen. If x approaches negative infinity means left, what does x approach positive infinity mean? Right. So if you're on the right side of this parabola, you're going up. Think about it. Doesn't it make sense that both of those are positive? Because no matter which way you go, don't you end up going up? That's why both of them are positive. Okay, now let's look at number 2. Go ahead and graph it. Not necessarily. Some parabolas open down. We'll get to one that opens down. Just wait. 3x squared minus 24x plus 38. Okay, once you have the equation typed in, you graph it. What's wrong with yours? Oh, yeah, there. Okay, so now let me pull up the page to all of those. All right, the first question is domain. What's the domain of that parabola? Right. No matter, you can go left, as it goes up, isn't it going left forever and right forever? So the domain is negative infinity to positive infinity. Now, to know the range, you kind of have to know where the vertex is. Where is that vertex? Okay, well, let's check. Let's go to the table and make sure we see a point that says 4, negative 10. Yep. And isn't negative 10 the smallest number in the y's that you see? Okay, so 4, negative 10 is your vertex. So that means the range is what? How low will you get on that graph on the y-axis? And how high will you get? So negative 10 with a bracket to infinity. Is the vertex a max or a min? A min, because it's the lowest point. It opens up. Where would the axis of symmetry be? X equals 4. Interval of increase. Which side of the parabola is increasing, the left or the right? So it started increasing at the vertex, which was x equals 4. And then it increased forever. So the increase is 4 to infinity. So that means the decrease was negative infinity to 4. Okay, now for end behavior. As x approaches negative infinity, that means what direction? Left. If you go left on the parabola, you're going up. So y approaches positive infinity. X approaches positive infinity means right, but yes, you're still going up. No matter which way you go, left or right, you're going up. Any questions? Okay, number 3. And think about it. With parabolas, these will always match. Like, you can't have one positive and one negative, because don't parabolas always go the same way? They're both going up or they're both going down. So it'll either have to be positive, positive, or negative, negative. You can't have one of each. Okay, number 3. Okay, well, we'll talk about how to fix that. Y equals 1/2, so I need to do alpha y equals n over d to get that fraction typed in. That's fine. X squared plus 5x minus 7. Now, like Isabella was saying, you can tell that the vertex is way down here. So watch what I'm going to do. You can do that, but I'm going to do it a different way. Right now, isn't the y-axis only going down 10 units? Well, I need to go down further. So when I go to my window, what needs to be changed? No. The y-min. We want to go down further, which would be minimum, right? Max would be going up the y-axis. Min would be going down the y-axis. It's currently set to negative 10. Don't we need to go down to negative 20 to see more of the graph? So once you type in negative 20, hit graph again. And now see how we can see 20 notches down the y-axis and we can actually see the vertex? Now, this one's still hard to figure out where the vertex is because it's at a decimal value. Okay, so watch what I'm going to do. Look at the board. Second table. If I look at these numbers, I see that I have a negative 19, a negative 19. What's negative 39 over 2? Well, what is it as a decimal? Yeah. You could just type this in. 39 divided by 2. It isn't negative 19.5, just a little bit lower than negative 19 and negative 19. So there's your vertex. To get to your vertex, you have to go left 5, down 19 and a half. See how the table comes in handy? Okay, what's the domain? Right. You can go left forever and you can go right forever. What about the range? The range has to do with y values. What's the lowest y value that graph will ever have? Negative 19.5 is the lowest y value it will have, but then it will go up forever. Okay, is the vertex here a max or a min? It's still a minimum because this parabola opens up, so the vertex is the lowest point on it. Where would the axis of symmetry be? X equals negative 5. You'd have to draw a line cutting through the x-axis at negative 5. Where is it increasing from? Negative 5 to infinity, because it's increasing from the vertex, which has an x value of negative 5, and then forever to the right. So negative 5 to infinity. Where is it decreasing from? Negative infinity to negative 5. And then for end behavior, as x approaches negative infinity, what does y approach? Positive infinity. And as x approaches positive infinity, what does y approach? Positive. It doesn't matter which way you go on that parabola, to the left side or the right side. You go up forever. That's why both of those are positive. Okay, for the remainder of the class, I want you working on your own on page 22. It's 3 more problems like these. Next week, when we're back on Thursday, we will be finishing this packet. Friday, we'll be starting the review for the CDA. The next Monday, we'll finish the review, and I'll take up your pink sheet, and then that Tuesday is the test. Yep.